This is Spider Control I 4.0 integration suite. With part 8, we will read out a CSV file and copy the cells to the SCADA server. Imagine we have a CSV file which might look like this, like we've generated in the previous chapter. We will program a function block logic with Spider PLC, and we'll copy cell by cell to an internal array of the SCADA server, and then visualize the data in the browser. So this video refers to the previous chapter where we generated a CSV file like this containing energy consumption statistics. I've made an example here which would show the energy consumptions of a day indicated in the first row, in the first column, the hour, so it starts at 0, 1, 2, etc. until 23 hours, and the value. The goal of this tutorial is to show how to open such a file and how to read out this data, how to display it in an HMI, how to copy it from a file to an internal structure of the SCADA web server. So the little project that I made to visualize looks like this. So I have defined an internal array, a two-dimensional array. So the first column will be showing the hours and the second will be showing the values. And I added a few bar graphs just to give you an impression of what could be done with that. So this is how it looks like when it's finished, and I would like to go through the code, through the programming of that. So for that I've prepared already a page which is called readout CSV. I will open that. And I will quick go through this logic, which is able to read out cell by cell of this CSV file. So how does it work? The idea is we have a button which would start the readout of this file. So this can be a signal that comes from a user interface or from the PLC or whatsoever. This will then set this impulse relay to 1, and this impulse relay will stay 1 for the complete campaign of reading out all of these 2 times 24 cells. So it will generate an initial trigger signal which comes in here and which will initialize this counter. So this counter is set to count from -1 to 24. So with the first trigger signal it will count from -1 to 0. So the first value which will be used for this counter will be 0. Then we have this compare unit which compares to the value of 24. So if this counter is through for the first time, it will generate a trigger signal for the second counter, which counts from 0 to 2. And this one again compares to the value of 2. So if this counter has counted through 1, 2, 0, 1 to 2, it will then generate the final reset signal, which is feeded back in here and which will reset this impulse relay. So this is how it will count 2 times through all of the cell values. We will feed out some signals here. So this is the trigger signal which will be used for the recipe load cell function. This is the row index from this first counter, and this is the column index from the second counter. So the next step is this function recipe load cell. So this can be found here in the recipe section, and I've just inserted this object. The source file I have indicated as a constant. In many real cases this could also be of course a value which can be selected by the user and can then be generated to a name scheme which relies on dates, on month, day and year or so. But here, to make it easier, I've just used this constant for this file which is called today.csv. We will then feed in the row and column information which we fed out up here, and we have a trigger logic. So the trigger is generated up here, and so this will trigger this recipe load cell to read out cell by cell, starting at 0, 0, going to 1, 0, etc., etc. When this operation sends a done, so this recipe load cell will use several cycles of this logic until it's done, because file operations are not so fast. And when it delivers a done as a result, this will generate us a trigger signal to write to this array. To do so, we have used this indexed array functionality. So this is this function here, which will use the same row and column information. It reads out or reads in the value from the recipe load cell, and will trigger as soon as the function block before has finished, and then write the value which was read from the file to the respective indexes. This trigger signal again will also be fed back to here, and will generate the next trigger to increment the counter until this counter logic finishes and resets itself, like explained before. So this is basically the functionality. What we've got here is just a simple reset logic. So this will use this function from these node ops, which will be explained in another video. It's just a very comfortable way to reset a complete array, a complete namespace which reside in these iCells OTF. Okay, so let's see how this works. So we make a build, save to archive, and start the debugger. Okay, so I will first reset the complete logic, so we can see now the array contains only 0, and with this button it will start, and it will now read cell by cell from the CSV file, filling up the first column and the second column, and then stop again. So once more we reset. Start it, we see the impulse relay goes to 1, the counter here counts up, this has now changed to 1, and the final reset, and we're through. Okay, that's it.